Okay, welcome to my laboratory. I just wanted to show people a quick experiment that I've been doing that's kind of interesting. It's testing two different things. It's testing the replacement of the coil with a Sallen-Key low-pass filter, and it's also an experiment in shielding using that construct. Two things I've been really meaning to get around to testing, but well, I ran out of solder on my last 6 kits here, so I'm waiting on the solder, and I thought, well, I might as well do this experiment. And it's kind of interesting. I don't know how definitive this experiment is, but it's sort of promising. It's not a total dud. So what are we doing? We've got a Sallen-Key circuit here. It's 2 resistors, 2 capacitors. This one is the ratio of these two, the square root of the ratio gives you the Q of the second order filter, low pass filter. This one is huge and this one is tiny. So we're replacing this tiny one with a plate, the intrinsic capacitance of a plate. And of course in that situation the ground connection is like the universe. So, and this one's really big, and indeed what we're doing here is we're using here is a 0.1 microfarad and 22K for these 2 resistors. You can change this resistor ratio too. I haven't messed with that yet. So we're driving it with 1 volt peak to peak from a unity function generator, and so the plate here is hanging off like where the capacitor normally is. And then behind that plate we have another plate that's larger, and we're driving that with the output of the op-amp. Now, since this is in a unity gain situation, the output should be the same. It should follow the input. So this should provide shielding and a very low impedance output. And indeed, when you remove the shield and add it, the difference between the two, you see a rather significant change in capacitance. The ratio to me that I'm seeing is like 0.7 change in capacitance. So it's not half, but it's still significant. So we're clawing back some of the intrinsic from the back of the plate here. And the Q we're getting is about, we're getting 33 volts out for a volt in, so it's about 30. And going by the capacitance ratios of the frequency ratios rather. Without the plate, it's resonating at 3.55 kilohertz. With the plate, it's at 4.26. And then we square that, and we end up with 0.7 for the capacitance ratio. And we also see this too with the peak to peak, the Q ratio, 24 volts. You can look at the peak voltages, and that gives you the Q ratio. So 24 over 33 gives you 0.7. So these are very, very similar, and that's, I think, what we would expect. And if you do the LT SPICE simulation, work backwards, you end up with 12 picofarads with the shielded plate, which is nice. It's a nice low value, and the input of the op-amp has some capacitance too, though it's actually low. It's like a 1 picofarad and 2 picofarads differential in common. So that's nice. So here's the circuit laid out on the breadboard, which probably has a lot of intrinsic capacitance too. It's 1/4 of a TL074. Here's the drive, the unity. The output isn't as spectrally pure as I was hoping. In fact, driving the scope with it seems to drive the trigger a little nuts. So I'm actually triggering on the output of the Sallen-Key. So here's the plate, and it's separated by, this is do-it-yourself polyester capacitor. It's just some drawing stencils. And the bottom plate is 2 pieces of aluminum electrically connected by an alligator clip. So here, let me put this back. I'm putting the phone down. I experiment around with this distance, and it seems like, I don't know, 4, 5, 6 millimeters seems gives you the best intrinsic recovery, which is interesting. And it doesn't seem particularly sensitive at all to mechanics, which surprises me. So this is the drive wire here, and this is the shield wire. And I actually tried spiraling them together, and that didn't work out so good. And I'm not quite sure why. But I was hoping that this connection could be, coaxial cable, but I'm not sure that would work, or at least not. It doesn't seem like it'd be working for this setup anyway. So what do we have on the scope? The yellow trace is the input, the 1 volt peak to peak. The blue trace is the output of the Sallen-Key. So you see we've got 1 volt in and 29 volts out. And we have a pretty good quadrature at resonance. So what I'll do here to show, well, I want to show you the shielding first. So here's my hand moving up and down. You can see, phase difference here. Here's my hand about, 3 inches away. Here it is about 1.5 feet. Right? So, but if I put my hand under here, right, here's my hand under, here's my hand not under, here's my hand under. I mean, this is like just very, very near plate, and it's not reacting much at all. So that, that might be good for, well, you're getting intrinsic back, but also it might be good for a performer on a stage situation where, you worry about people in your control zone. So just to have some kind of idea of stability is really the main thing when it comes to, other than resolution, we want to see like how stable it is, and it's kind of hard to really do that without an oscillator kind of set up a feedback kind of situation. But we can kind of take a look at it by jacking up the voltage here, or the gain rather, and then really jacking up what we see on the screen. So looking at that, it's stable as that, And I'm also I'm averaging 8 here. You can see the averages. If I turn the averaging down, you see the noise goes up quite a bit. And that's this dusk lamp. It's very adversarial. But you can see that we can average it out with 8. So here's my hand, maybe 1.5 feet above the plate, maybe 1 foot. 6 inches. Oh, that's maybe 1 foot there. So 1.5 feet. So you could probably make just from this sort of measurement, you could probably make something like a Theremin. I don't know if this is really pro level stability or not. My Theremin can see me a couple meters out sometimes. So whereas I don't know. You'd have to set it up. It is just a preliminary experiment. So I guess that's kind of that. And, oh yeah, and then you can see the bumps here are because my D-Lev is actually plugged in and very near the plate too. So you get some bumping there. Okay, well, I guess that's it. All right, thanks for watching.